Rewst 205. This brings us to the end of the 200 series. We're going to be consolidating a lot of the things that we've talked about throughout the 200 series and giving names to some of the key concepts, key ideas that we've sort of touched upon throughout the 200 series. Again, a lot of what we really focused on and emphasized throughout this series are what are the things that we need to know in order to maximize the value of our automations while diminishing the amount of things that could take away from that value. A lot of these things come in a lot of different forms, whether we call it tech debt or something else. And so one of the more formal names to these things that take away from value are known as anti-patterns. Anti-patterns just very simply are things or principles that actually are very, very common, but are counterproductive or, again, take away from the value of the solutions that we are creating. They come in the form of many different things, but oftentimes it increases our tech debt, increases the complexity of the things that we are building, making them harder to modify, to manage, to change, hard to scale. So anti-patterns are the things that we want to avoid because they are, generally speaking, detrimental to the overarching solution that we have created. So instead of implementing anti-patterns, we should also consider what should we do instead. So we want to avoid anti-patterns, but what are we doing instead of these anti-patterns? The opposite of anti-patterns are known as design patterns. These are common solutions that have been sort of distilled down to us, right? The collective wisdom of developers, software architects, etc., have sort of given us, in a sense, these best practices in the form of what we call design patterns. Design patterns are used to help resolve a lot of the common issues that we have with anti-patterns. And so what we're going to do is just kind of investigate some of these two things. What are the anti-patterns we should avoid? What are the design patterns that we should adopt and implement? So let's go ahead and dive in. So let's dive into some of the common anti-patterns that just arise. And wanted to start off this anti-pattern discussion with this one known as the cargo cult programming anti-pattern. So cargo cult programming originates from a very interesting story, but we'll skip the story for another time. Cargo cult programming, in essence, means when you see something done and then you immediately grab it and then implement it without any sort of understanding as to how the solution works or why that implementation is done in the first place, right? Oftentimes this results in you go on the internet and you copy and paste something, or you see somebody's example of a workflow, you see that it produces a specific outcome or result, and you just immediately do the exact same thing without any sort of rhyme or reason behind it. And so why we want to highlight this one first is oftentimes with cargo cult programming, right, our intentions are good. We see things work and we want to do the same thing in our instances, but without any sort of discretion or further thought into the solution, we might end up doing something that could do us more harm than good down the line, or just might not be needed. And so a lot of anti-patterns in and of themselves usually arise from this pattern, anti-pattern here, right? We see something, it works for that situation, and we try to do the same thing. And so while there isn't a formal design pattern to counter this anti-pattern, the idea here with the cargo cult and most of our anti-patterns is most of them could be resolved just with that continuous learning and that continuous questioning. Oftentimes just asking, why is it done like that? Or is this the right way to do it? Can lead us in the right direction into discerning what is indeed the best way to do something. And in this continuous learning, we have a lot of different resources available to continue the learning process. We have CLUCK University, where we continuously try to get more content available to you guys so that you can learn. We have things like Discord to help out with, we have things like Discord to get help from the community. And there's always the help that we can do on our own, whether it's reading a book, watching videos from CLUCK University, so on and so forth. So one of the most common anti-patterns, cargo cult programming, just grabbing something we've seen and hoping that it works. The next anti-pattern is just as common as the first. This is the golden hammer anti-pattern. The golden hammer anti-pattern goes like this. If you have a hammer, everything looks like a nail. The idea here is that you may have one specific tool, one specific methodology that you try to implement for as many problems as you can, or every problem that you can. For me personally, my golden hammer anti-pattern is generally list comprehension. Whenever somebody says or asks about list, my mind immediately jumps to list comprehension. And sometimes it's the right solution, sometimes it isn't. And that's usually the anti-pattern that I have to fight the most. Can I use list comprehension for all list problems is sort of what I struggle with. So golden hammer anti-pattern. This is something that we want to be very conscientious about because there are very good tools that do very good work. We, again, just like cargo cult programming, want to be discerning on whether or not our favorite tool, our favorite methodology, our favorite syntax is indeed the right thing to be using. With the golden hammer anti-pattern, again, we could fall into a lot of the common issues of all of our anti-patterns. While yes, we could implement our favorite tool or method, it could be inefficient, it could cause maintenance problems, it could put us down a road where we're kind of stuck with something because we decided to use this thing instead of a more flexible or more suitable or more modular something else. Now, the opposite of the golden hammer anti-pattern, in the programming world, there's something known as the strategy design pattern. This is basically a logic, this is basically a programmatic logical decision maker, if you will, where you have different modules that can be used to provide solutions for different situations. And so taking that thing or that concept in mind for Rewst, we could do something very similar, not only in the conceptual world where we should think about the best strategy to implement in any one problem, but also within our automations as well, where we can use things like sub workflows, as we've discussed in previous sessions, to have implementations of specific use cases or specific situations or specific functionality. And we can use no-ops to help guide the flow of our automation to lead into these different situations. If this, go do that. If something else, go do something else, et cetera, et cetera. So 2 parts to this, how we think strategically, what is the best solution, as well as we can implement something similar within Rewst. We've discussed this one before, but just running through it one more time. Another big anti-pattern that we really want to tackle is the God workflow anti-pattern. This one here is having a workflow that has too many responsibilities, where it's trying to do too much at one time, right? It could be trying to both create, update, delete a user, whatever the situation. These workflows are huge. They have a lot going on, and it's just very difficult to manage. They're very complex, so it's difficult to understand and comprehend, especially if it's not yours. And they're very inefficient to reuse. While yes, a workflow that does everything can be used to do everything, there might be a lot of inefficiencies trying to route through a workflow to figure out exactly what specific thing you're trying to do. So just one example of a workflow such as that. The opposite of a God workflow is using the single responsibility design pattern or the design principle, right? This is focusing in on creating things that have one single job. They're designed to do one specific thing, whatever that thing is. We touched upon this a lot in Rewst 204, where we discussed modularity, abstraction, and sub-workflows. We want to use those same ideas and principles when we're creating our own automations, our own workflows. Focus in on a sub-workflow and create it so that it is focused on one thing, whatever that one thing may be. Right, so if we were to isolate the most common anti-patterns in Rewst, those are the ones that we want to keep in our minds the vast majority of time. Let's talk about some other ones that could sneak up on us. This one here is known as the magic strings anti-pattern. This one here is where you are putting very specific values or hard-coded values into our code, right? It's forcing just a singular value, and it really limits our capabilities rather than having something like a variable. So to resolve it, all we do is variabilize what the thing or the literal thing that we put in there is. So instead of putting somebody's email address, for example, we can have a variable that will capture the email address somewhere else. So a lot of opportunities for us to watch out for these, especially in the Jinja world, right? Again, we want to do our best to use variables rather than putting a literal email address or a literal number wherever possible. That way, it gives us more flexibility when we use a variable. With a hard-coded value, you only get that one value. With a variable, it also makes it more readable. By naming our variables very appropriately, it allows us to be able to see exactly what that value is for. Right? If we put somebody's email address and we don't know who that someone is that just a random user? Is it an admin? Is it a customer? Just having the email address there is a question mark. But if you name a variable like admin's email, then it's obvious. And then makes the maintenance of things much easier. Again, if you don't know whose email this is in a hard-coded or magic string, makes things more difficult to figure out. What is this email address here for? Whose email is it? Right? You have to spend all of that time trying to figure those things out. Next anti-pattern to be considerate of is overfetching, or getting more information, more data than we actually need. Right? There are instances where we might get an entire user object, but the only thing that we need from that user is just their ID or just their email, right? While yes, this is a very small example, if you do this at scale, right, this could be a lot of additional data that you either have to parse through or write some logic to try to filter it down. And if you only just need one thing, then we should try to do our best just to capture that one thing that we need, depending on what it is. So there's a number of different ways to address this. Let's talk about, well, some of them. In some of our actions within Rewst, there are the ability to add filters or filter queries so that when we implement an action, let's say get a list of groups, we can put specific parameters or filter queries to specify which groups we actually want to get. So for example, if I only want to get groups with that have been created in the past 30 days, right, we can add a filter query to do that. Or only give me the list of groups that are active, can do something like that too. Along with that, as with the previous example, let's say I have a list of users, and the only thing that I need from those users is their ID. In some of our actions, we have this section here known as select. Select allows us to, as the name kind of tells us, pick and choose which attributes of the action we want to capture. So in this example of a user, instead of getting their display name, their email address, their user ID, et cetera, in this select field, I can just say, just give me the ID. And that's all that'll come back to me. Again, only some actions have this, and this is dependent on us knowing what attributes we want to capture and how they are displayed or labeled within the integration. So there's a little bit of additional work we might have to do, but again, it helps us filter down and just get exactly what we need. All right, next one here is another common one that we need to be cognizant of in the Jinja world. This is known as the redundant calculations anti-pattern. And this usually happens within loops in Jinja. This could sometimes happen in a workflow, but the idea here is that we're performing a calculation over and over again, and it just is very taxing. So in this example here, we have the calculation for tax, right? And in one of the lines here, what we're actually doing is we're just calculating the tax rate again and again and again. So what we can do instead is a technique known as hoisting. What hoisting is, as the name kind of describes, you hoist out or you take out the redundant calculation from the loop, and then you move it outside of the loop. So rather than having the calculation run again and again and again, you just run it one time, and then you can bring that value into the loop. So something like this. So if you have a specific tax rate and you want to multiply that tax rate for each item that we are calculating for, right? Bring the tax rate out, do the calculation outside of the loop. You now have a numerical percentage that makes sense, and then you can bring it into the loop like so. One more example here is something that we saw over in Rewst 104. In Rewst 104, we created an options generator, and that options generator is giving us a list of groups that the user is not a member of. The redundant calculation here begins on line 5. We are having a second list comprehension executed, and the redundancy here is that every group that we are looping in on line number 4, here, the CTX all groups, each group in that list, what we end up doing is recreating the second list here on line 5 to line 8. So in our first list, all groups, grab a group, and then on line 5 and 8, create the list of group IDs that the user is a member of. And we're doing that again and again and again. Next group from all groups, once we have that, recreate the list. And so we're effectively recreating the list we're recreating the list for every single group inside of all groups, right? And this could be very taxing if we're dealing with hundreds of groups, recreating this list hundreds of times, when if we used hoisting, we can hoist out that second list comprehension and run it just one time. So that way we don't need the calculation to be executed again and again and again. Just run it once, and then you can bring the result back into the original code that we have here. So that's hoisting. Rather than having a loop execute that calculation again and again and again, take it out of the loop so it's only calculated one time. That's the essence of hoisting. Let's talk through some other common anti-patterns that we oftentimes run into. This one here is Rewst specific. This is in regards to with items. With items has this setting of items concurrency where we can designate how many items the with items is going to execute upon at any given time. So we have a range from 1 to 10, 1 being the minimum, 10 being the maximum. If it's too low, it's going to take some time, right? If you're chunking through hundreds of things and you leave it at 1, it's going to be a little bit, right? If time is not of the essence, it's not a big deal. But if it is, then we probably want to consider putting the number up a little bit higher. Contrast that with the opposite. While 10 is the limit, again, if we're working through thousands of things and the execution is done really, really quickly, sometimes the integration that we're working with doesn't like that we're hitting or accessing its API so many times in a specific time frame. So it could incur API limits from our integration if we do too many. So we have to find a nice in-between, and just like with our first, or rather our second anti-pattern with golden hammer, right? We have to think about our specific solution, right? What's best for each specific situation. Next one here, just thinking about the future, right? There are going to be times where we build a workflow and we're done. We sort of, wash our hands of the workflow and we think we're never going to see it again, or we might not see it for a really, really long time. And so the issue with that is when that really, really long time comes and we have to come back to our workflow, if we did things in a way that's doesn't have descriptive names, is God workflows, etc., right? We sort of incur that original tech debt that we just talked about. Takes time to figure these things out, takes time to figure out why we named things the way they did or the way we did. Just takes a lot of time to come back and reacquaint ourselves with the workflow. Combine that with other factors like scaling, right? If we want to continue to build upon a workflow and we've made it hard on ourselves, then again, it takes more time than what was originally necessary. So taking care of ourselves in a lot of different ways, the way we name things and the actual architecture so that we can continue to scale. Again, leveraging a modular design so that we give ourselves that flexibility down the line. Another part of not building for the future is this idea of being tightly coupled with, in this case, tools, but it can also be other situations. The idea of tightly coupling in the sense of we build something so dependent on a system that it's very hard to break away from it. There are some situations where we can set ourselves up for success, to be flexible, but this is something to keep in mind. We might not always be doing things like switching ticketing systems or switching our RMMs, but we still want to be able to build in a way where if those situations come, it's not as difficult as it can be. So just simple things like naming. So instead of calling something this PSA, we can keep it generic, like make a new ticket instead of make a PSA's ticket, for example. Or the way we name variables, instead of something like PSA underscore ID, it can just be like, ticket ID or PSA ticket ID instead of, what I'm trying to say here is instead of using vendor-specific naming, use generic naming instead. So that way, when we do decide to make switches, it's much easier, right? The generic name of a variable is still in play rather than a vendor-specific name. And this also alludes or ties back to one of the examples we had in Rewst 204, where we can use this idea of sub-workflows to encapsulate a lot of specific process or tasks that are vendor-specific. So if there's something that we're doing where it's a ticket is created, we grab some details from Rewst, add it to the ticket, right? We can take all of that and put it in a sub workflow so that the actions of the ticketing system are contained within that sub workflow, so that if we ever do change, we just need to go into that sub workflow and then switch out those actions for the ticketing system from the old one to the new one. A couple more Jinja things that we want to discuss really quick. A very common one in Jinja as well is assuming that we're going to have a value or a result in a specific variable, right? So things like this, where you do, your two curly brackets, ctx.variable, and we expect the value to be there. 80, 90% of the time, that's probably true, but there might be some rare instances where that is not true. And so another example of this is in a list, right? If we do some sort of list comprehension, or we're retrieving a list from somewhere and we expect something to be there, like go grab the first item of the list. If there is no first item, then we're going to get an error. And so one of the easiest ways to resolve this is with the D filter. Filter D stands for default, and this will assign a default value. If we are not specifying what that default value is, it's going to be an empty string. Or we can specify what the default value is. For sure. No pointer exceptions. Anywho's, so very simple for, again, majority of the use cases. Whenever you have a variable that you're retrieving a value from, you can just put the D filter. It really doesn't have any major impact in regular functionality, but will catch things if there is no value. Another thing to note here is that empty string, so if we just use the D filter as is without specifying a default value, empty strings are falsy, right? If you do a conditional statement, it'll come out as false. Right. Other things we can do here, just having very simple if-else statements to check to see if there is a value before assuming that we're going to pull something from it. Right. Oftentimes, though, when it comes to things like lists, a lot of the accounting for empty results are in situations where you're doing some sort of calculation. Right? Most of the time, if you're just getting a list of something, most of the time you'll get something. Again, we should be putting this type of error handling or this type of checking to make sure that we indeed have something before doing whatever it is we need to do with our data. Next one here is in regards to Jinja, a lot of, again, other Jinja related things, especially as we're like diving deep into making Jinja do a lot of more complex work with our data. As with most things, when we're dealing with really complicated Jinja, it's usually as a result of thinking about, hey, I want to implement something, and I'm going to take exactly as I think about something and just put it down on code. So something like this, right? There's a lot to look at here. And the thing that I just want to highlight here is this Jinja code is complicated because there's a lot of calculations that are being done just in this one, we'll call it this one Jinja editor or this one chunk of code. What would be really helpful and what could help simplify and make this more readable is abstracting out a lot of those calculations into their own context variables, into their own data aliases. So that way, instead of doing a calculation like this one here, let's go put it in a variable, right? Do all of the calculation somewhere else, take the result and store it in a variable. Oftentimes, this is a very simple way of just simplifying our Jinja. Right? You have a whole bunch of stuff that's happening. Go shove it in a variable so that at the end result, we can have something like this. Same chunks of code, But again, a lot of the complicated code is abstracted out. We're only revealing what's most necessary, the variable. Right, so it looks much cleaner with good descriptive naming. We can get a lot, or we can infer a lot of the functionality of what's going on. So simplifying Jinja, tucking away some of the complexities into their own data aliases in places that make sense. Next one here, you just want to be considerate of maintenance. Things are changing, APIs update. So when necessary, right, we want to go back and maintain and update our workflows. And sometimes the maintenance is just, hey, I just needed to get something out quick and I needed a little bit of automation, right? Little automation is better than no automation, and make that I'll come back and make improvements. So just making sure that we do come back to maintain, update, and ensure that our workflows are doing exactly what they're supposed to do. One more here. This is more of a symptom of the God workflow is the flying spaghetti monster workflow. Again, this is a symptomatic. We know that we've hit a God workflow when we have workflows that look like flying spaghetti monsters. So, right, when we see our workflows are becoming increasingly complicated, this is where we should think through and take a step back and see how can we make it look just a little bit better. Looks aren't always everything, but again, when it's very hard to figure out what goes with what, we should probably start thinking about things like modularization. How can we take a bunch of stuff and put it in a sub workflow when it's most appropriate? Oftentimes, again, when we're dealing with this, two big things that we're going to see most in a spaghetti monster workflow is lack of modularity. There's probably little to no sub workflows in a spaghetti monster workflow, and then flow control. Right? Flow control is usually taken care of by the no-op. And when we have a no-op with 8, 9, 10, 11, 12 transitions trying to branch off to every little thing, we should be considerate. Are 12 transitions needed? Do we need to account for these 12? Are there ways where we can try to reduce things down if possible? There might not be, but oftentimes if we have a transition or a single no-op that has so many transitions, you might want to think through the problem a little bit more. So some issues there. And then again, a lot of the other common ones that might be happening, things like tight coupling, lack of documentation, and things like magic strings. All right, just a few more, and then we're going to be calling it good. This one here, just talking about truthiness and falsiness once again. Jinja has the ability to evaluate data types like Booleans. So when we saw this in Rewst 203, if you have an if statement, you can check to see any other data type. And if there is a value in that data type, you'll get a true. And if there is no value or an empty value, then you're going to get a false. Right? This gives us the ability to have implicit versus explicit conversions. When it comes to anti-patterns, the big thing to note here, once again, is that implicit conversions, when we're checking for whether or not something is empty, implicit conversions covers a wide range of cases. Things like, is there a value? Is it not none? Things like that are covered by implicit conversions. Is there something there or not? Is basically the end result of an implicit conversion. Whereas an explicit, you would have to list out every single thing that you're checking for. Right. So in that way, it helps us reduce the amount of code that we have in Jinja when we're doing things like if statements and so on. So something to be very cognizant of, just helps us shrink down a lot of code. And this last one here, I want to come back to notes and comments. When we began this journey, we highlighted 3 different places that we're going to be experiencing tech debt the most, or these anti-patterns. We've hit a lot on workflows. We've talked a lot about code. And then this final one, just to cap everything on, or cap everything off, is with notes and comments, or documentation. When it comes to documenting in code, we oftentimes have to document because there's a breakdown in how we express ourselves in the code and what we're trying to say. Right? Sometimes it can be very difficult to figure out how do we express ourselves in code so that it's clear and concise. And sometimes that's not always easy. And so we have to default back to everyday English, right? Not all of us are fluent in Jinja, and so we have to use everyday English to sort of fill in the gaps. With that, we have to be very careful in how we decide to document, add notes, and comment, because the worst thing we can do with our comments is create lies, whether intentional or unintentional. Sometimes comments can be misleading or to be or not to be. That's pretty good, yeah. So when it comes to notes and comments, we want to do our best to avoid some of the common things that could create comments that end up lying or misleading or just maybe becoming outdated down the line. Right? We should not use comments in a way that tries to make up for either bad Jinja or bad code or bad workflows. Right? We still always want to do our best to make the workflow and the code speak for itself, right? So we have to do our best to make it do that by applying a lot of the concepts that we've talked about. So let's talk about what bad code, or bad comments, I should say, looks like. So comments that are redundant, right? These are the comments that don't really provide any additional value or information that's not already there. So this is you put a note box over a graph action, and the graph action is list users, and your note box says list graph users. Get it? Very redundant, right? Misleading comments, right? This is hey, we are not being, this could be a lack of clarity, or just, again, provides information that's not true or partially true. So we want to be very careful with that. And this last one here is just leaving in commented out code. So if you have a big block of Jinja, right, and then you comment out some code and leave the commented out code there, creates a lot of questions there for other people who are looking at it. Is the code still necessary? Are you going to use it again? Why is it here? Does it need to be deleted? Should we delete it? Maybe they left it here for a reason. It just kind of creates this ripple effect of why is it here? Some examples of good comments, though. Comments that explain intent, right? Especially in a workflow. These are probably the best kind of comments that you can have. Put a note over a couple of different actions and explain what is the outcome, what's the result of these actions once they're done. Right? It ties back into the informative comments, right? These are the comments that give you information that you couldn't have known without the comment. And finally, any notes that help just clarify things. Right? Again, whether it's due to difficulty in conveying the thought or just hard to read something, any sort of comments that provide additional clarification. All of this just so that we can focus in and create workflows where we can look at them and say, hey, this is fine. This is a good workflow. It's not something that brings us dread or has us say choice words. And so with all of that, this brings us to the end of Rewst 205, brings us to the end of our 200 series. So I want to thank you for being here and dedicating time towards this.